All right, welcome everyone. Excuse me. This particular lesson we are actually is entitled Substitution, but actually what it is we are solving a system of linear equations by using substitution. So let's go ahead and jump right in and begin there. Okay, so the first one, there are 4 questions on the 5-minute check. Please keep in mind that previously we have been solving by graphing. So you're going to want to answer these. So again, you're looking at it and then you're picking out the one that goes with it. And then the second one, pause as you need to work on them so they don't, you don't have to just run it through very quickly. You can pause when you need to. Okay, so you need to write that one down. Here's a second one. You'll need to write that one down. Now keep in mind, they're giving you the equations, but they're also giving you the graphs, so these should be pretty easy to do. Okay? Now, this one was a word problem. I did leave it in because you got to be able to do this. Later on in our in this chapter, you're going to have a whole entire lesson that's nothing but word problems, so you got to get practice in learning how to do those. All right? And then the last one, notice I didn't give you a graph, but I do ask you what the solution is. So I would like you to write that one down. So there were only 4 in the 5-minute check. So let's go ahead and begin. Okay, so what we did in the last lesson is we solved systems of equations by graphing. Now you're going to solve them using substitution. This is an algebraic method. So you're not going to need the graphing calculator as much here because we're not graphing. We are actually solving these algebraically. And you'll also be using substitution to solve systems equations in real word problems. Key word problems, you guys know what that means. Okay, so let's go ahead and begin. So our only vocabulary word that's new is substitution. Now, you guys are familiar with substitution. If you play a sport, you know what substitution is. Substitution is where you replace, in a game, you replace one player with someone else. You guys do it all the time. Substitution in math means exactly the same thing. You are replacing one quantity with something else. And so what you see here, solving by substitution, basically what you try to do, if it's not already done, you try to get one of the variables by itself. And then you take that one and substitute it into the other one. That's what they're telling you. And then you solve it, and then you plug the answer back in to get the other answer, and you have to write it as an ordered pair. You're going to see me do that here. So just a heads up, we're going to go ahead and get started. Okay, so here's our first problem. Now I'm going to show you how to do this, and then I actually have 2 examples that I'm going to do that aren't worked out like this, just so you'll be able to see how that works. So here you have substitution. You're using it to solve the system of equations. The first one is y equals negative 4x plus 12. The second one is 2x plus y equals 2. If you notice in the first one, the y is already by itself. So I'm going to replace this y with this quantity. And you see them do that. And so you see in parentheses, it was 2x plus y equals 2. So 2x plus y, using this information, equals 2. And then from there, you just simplify and solve, okay, so that you get x equals 5. Okay, then what you do is you take that 5 and you can put it back in either of the equations. I always go back to my originals. I don't know why, I just do. I think my Algebra 1 teacher told me that. And so you're going to replace the x with 5. So you're going to have negative 20 plus 12, which is negative 8. So your ordered pair or your solution is 5, negative 8. Guys, you need to write your answers like this. It's just much easier to grade. Okay. Now, at this point, rather than going straight to the next example, I want to do a couple of problems with you. So I'm going to show you that. I'm going to pause for just a second. Alrighty, so I put up the first problem there, and so what you see is we have y equals 4x minus 6, and then we have 5x equals, I'm going to put this on so I don't mark it, 5x plus 3y equals negative 1. So you notice we already have a y by itself. So I'm going to replace this y with this quantity. So let me show you how that looks. Okay, so I am actually going to, let's change the color because it's in black. So what I'm going to do is I'm going to have 5x plus 3y equals negative 1. 5x plus 3 times 4x minus 6 equals negative 1. Notice that this y has now been replaced with this quantity. Now we're going to work on this. Okay, so I have 5x plus 12x, I distribute it here, minus 18 equals negative 1. Distributive property is all I've done here. Now let's combine like terms. Don't just start subtracting. You only do that if you move to the opposite side, not on the same side. So I'm going to have 17x minus 18 equals negative 1. I'm going to add 18 to both sides. So I'm going to have 17x equals 17. Let's raise that a little bit. So you get x equals 1. So I'm now halfway there. Now, what I'd like to do is I'd like to know, and I'm going to move that over here. I want to know, I have x, I need y though. So I'm going to use this equation. And yep, there it is. I'm going to replace this x with the 1. So I have y equals 4 times 1 minus 6. You can plug that straight in the calculator or figure it out. So y equals 4 minus 6, so y is negative 2. So my answer is going to be 1, because that's x, and then negative 2, because that's y. And there's my answer. Okay? We're going to go down and we're going to do another one. So hold on just a minute. Okay, now here is our second problem. Okay, and so same thing. I don't know why, but they always do with y equals. So notice that in the second equation, y is by itself. Okay, so we're going to replace this y with this quantity. Again, let's go with a different color. And so I have 2x plus 5y equals negative 1. So I'm going to have 2x plus 5 times 3x plus 10 equals negative 1. And now I'm going to do the same thing that I did. First of all, I'm going to do some distributive property. So you have 2x plus 15x plus 50 equals negative 1. So 17x plus 50 equals negative 1. I'm going to subtract 50 from both sides. Okay, let's just move that just a little bit. Okay, so I'm going to have 17x equals negative 51. I'm going to divide both sides by 17. If I'm right, that should be negative 3. And this is where, if you're not sure, pull out your calculator, which is what I'm doing now. And I'm going to do 51 divided by 17. 51 divided by 17. Yep. So the answer is negative 3. Now that I know what x is, I'm going to substitute it back into this one. Now, you could use this one, but to me this one's easier. That's why I'm using it. So y equals 3x plus 10. Y equals 3 times negative 3 plus 10. So y equals negative 9 plus 10. Y equals 1. So my ordered pair is negative 3, 1. Okay? So a couple more examples just so you can see kind of what that's like. And then what we're going to do now is we're going to go to the next page. And here's one for you to do. So take a minute, do this. You're going to need to write this down because you're going to need it for the form. Okay? And then I'm going to go on. Now, here, what we have is, this is an example of where it's not already in, there's not a variable by itself. So that means you've got to isolate one of them. So this one actually is perfect. And so you notice that the only one that has a coefficient of 1 is this x here. So what we're going to do is we're going to solve this equation for x, which means we're going to add 2y to both sides. So we get x equals negative 3 plus 2y. All right, so that's the first step. Now we're going to do what we've been doing. We're going to replace that x in the other equation with that negative 3 plus 2y, or 2y minus 3, whichever one you wrote. Okay, and then we're going to do distributive property. We're going to combine like terms. We get y equals 3. Okay, so take a minute, pause if you need to. Then, remember, we're going to take that 3 and we're going to substitute it back into one of the two original equations. I would have picked this one too because it's smaller and it seems easier. There's nothing special about it, it's just how much work you want to do. So this is going to be x minus 6 equals negative 3. You're going to add 6 to both sides, so x is 3. So your answer is 3, 3. Okay? So now, again, before we do that, we are actually going to do, I'm actually going to add in a couple more examples of us having to do that. Because that's, for most of you, I think that's probably going to be the hardest thing to do. Let's do, okay, So hold on just a moment. Okay, I'm just going to pause this for... Okay, here's the first one. I just hand wrote it instead of typed it because I just wanted it to go quicker. So notice that this one is the only one that has a coefficient of 1, this y. So what I'm going to do is I'm going to solve this equation for y. I'm going to do that by adding 3x to both sides. So I get y equals negative 13 plus 3x. Or if you prefer 3x minus 13, that's fine. Now I'm going to take this equation, which is our 4x plus 5y equals 11, and I'm going to replace this y with this quantity. So I'm going to have 4x plus 5 times, just so you see, negative 13 plus 3x. You know what, let's clean that up because that looks a little hard to read. Okay, so negative 13 plus 3x, okay, equals 11. Now it's just a matter, guys, of us just distributive property and solving and finding x. So we're going to have 4x, whoops, not a plus, minus 65 plus 15x equals 11. I'm going to put these two x's together, but you're not subtracting anything because they're on the same side of the equal. So 4x plus 15x is 19x minus 65 equals 11. Add 65 to both sides. So 19x equals 76. I'm going to divide both sides by 19. Excuse me. So I think 76 divided by 19. Let's try that again. That should be 4. Okay, so x is 4. Now that I have x, I'm going to actually substitute it back into this one instead of this one because I know I did that right. So then y equals negative 13 plus 3 times 4. Now keep in mind, in order to check these to see if you're right, you plug your ordered pair back into both of them. If it works for both of them, you're good. So y equals negative 13 plus 12. Y is negative 1. So my ordered pair is 4, negative 1. Put parentheses around it, and then I'm going to put a box around it. Okay? So there's the first one. Now we're going to try another one. Okay? Again, please feel free to pause because these are just examples. So our second one that we're going to do is x minus 3y equals negative 9. And then we're going to have 5x minus 2y equals 7. X already has a coefficient of 1, so I'm going to fix this one. Okay? That means I'm going to the next step. So I'm going to add 3y to both sides. So when I do that, I get x equals negative 9 plus 3y. I'm not going to replace this x with this quantity. So 5 times negative 9 plus 3y minus 2y equals 7. So this is negative 45 plus 15y minus 2y equals 7. I'm going to combine these two because they're like terms, they're on the same side. So negative 45 plus 13y equals 7. I'm going to now add 45 to both sides. I don't want to move y because then I'm going to have to do more work. Okay, so then I'm going to move that a little bit. So we got 13y, and then 45 plus 7 is 52. Okay, I know that when I divide both sides by 13, I get y equals 4. I know that because I play a lot of cards, and 52 cards in the deck, and there are 13 cards in each suit. If you know anything about cards, you got it. Okay, so now that I have this one, I'm going to replace, substitute this 4, because again, keep in mind this is substitution, replacing one thing with something else. So I'm going to replace this y with 4. So I'm going to have x minus 3 times 4 equals negative 9. You could have also substituted in this one, whichever one makes you more comfortable. It doesn't matter. So x minus 12 equals negative 9. I'm going to add 12 to both sides. So x equals 3. So 3, 4. And it's always x comma y, so pay attention to which one you're writing first. Because I will take off if you just get the order wrong, because it is wrong. Okay? So now we have that one done. Okay, and let's go to the next page, and you have one to do. Okay, so now notice that you need to solve it. I would help you out with, I would get y by itself here because it just has the minus. It's not a big deal. You're going to subtract 3x and then divide by a -1 and then substitute it in for this y. Okay, so feel free to pause so you can work on this one. And let's go to the next one. Now, keep in mind that when we graphed, you also went through an instance of where you had one solution, which was consistent and independent. It's where the lines crossed. You had many solutions where the lines were the same, and you had no solutions where the lines were parallel. So that can happen here, guys. It can happen here. So what we're going to do is walk you through an example of one. So they solved the second equation for y. You could have done x, it didn't matter. And they end up with y equals -2 minus x. Replace this y with -2 minus x. When you do that, whoops, let's go that way. Okay, you end up with 2x minus 4 minus 2x equals 8. Guys, 2x minus 2x is 0. So you have -4 equals 8. A lot of you, when I'm noticing these, you keep working it even though there are no variables there. Guys, this is never going to be true. -4 can never be equal to 8. This is an example of a no solution problem. You can check this by plugging this into the graphing calculator, and you'll see that these are parallel lines. You also should have noticed that when you look at the equations, if you double this, these are going to fall out. Okay, it's almost the exact same. This is the only thing that's not going to fall out. So that's why you do that. Okay, and really it's just a matter of working it. So I'm not going to do an additional example of this. Okay, and then here's one for you. So hopefully you sort of notice that if you double this one, you get this one. So hopefully that's a hint on what this answer should be. Now, for the next one, okay, this is where you're having to write your own equation. Now, I'm not going to have you do one of these, but I just want to walk you through this one, okay? So we have a nature center charges $35.25 for a yearly membership and $6.25 for a single admission. Last week, it sold a combined total of 50 yearly memberships and single admissions for $660.50. So how many memberships and how many single admissions were sold? X is the number of yearly, Y is the number of single. Okay? So if you notice, if you do X plus Y, you have 50 memberships total. That's one equation. And if you do the sales on the yearly plus the sales on the single admission and get your total, which is $660.50, that's your second equation. So that's where these two equations came from, was just writing down if you do the number sold, because you have that information, and then how much you made. Okay? You now can use substitution to solve it. And so we subtracted y from both sides. We solved it for x. We substituted it back in. Okay. And then here you go. Okay. So combine like terms here. That's how you got this step. And then you're going to subtract this number. Notice they're both negative, but if you divide a negative by a negative, you get a positive. So you find out the answer is 38 for y. Okay, so what that tells me is substitute 38 in the equation. X plus y equals 50 because it's easy. X is 12. So you sold 12 yearly memberships because it's X comma Y, 12 comma 38, and 38 single admissions. Guys, there you go. Okay. Now, this next one is working with percents of solution. And so you can make this one X, and I'm sorry, you're needing 25. So you'd make this one X and this one Y. And this is one I would like to do with you later at another time because I think we've done enough today. But please just kind of keep that in mind. I'll show that one to you again later. Okay? And so we are done. So I will see you on the next one.